Hey everyone, it's Greenwood again with another tutorial video. This one today is about finding slope from a graph, and so I wanted to kind of go over this again since we talked about it in class. So I'm going to give you a little bit more in-depth tutorial. So here we go. So remember that slope is always rise over run. So I'm using orange for rise, or excuse me, purple for rise and orange for run. And so from a graph, it's really pretty simple. We just count the number of boxes, but we got to make sure to watch our scale. Okay. So we'll do that here in a second. Um, and then we need to determine if our slope is positive or negative. So determine that we always go from left to right to determine if it's increasing or decreasing. Okay. So we'll talk about that here once we identify our slope. All right. So this first example, I have the points 3, negative 2, and negative 3, negative 2, and 3, 6. So I'm going to use purple for my rise. I'm going to count. So if I'm looking at my scale, I notice that this distance of 4 boxes is from negative 2 to 0. So that's 2. So then I notice that this must be 1 for 2 boxes. This is 1 more, another 1 for 2 boxes. So each 2 boxes must be 1 unit. Okay. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. So that means my rise is 8. And then my run, I'm going to count 1, 2, 3, 4, 5, 6. So my rise over run is 8 over 6. So that means my slope, it's as simple as saying 8 over 6. Okay. So then now let's talk about 2 more things here to finalize our answer. So is our slope positive or negative? And then can we reduce it? So if I look at these values and see where we're going. So if I look at my line going from left to right, so here's left and there's right. So as I move this direction, what's happening to the green line? We can see that it's getting bigger. Those values are becoming larger. So here my values looks like about negative 3/4 or something. Here my value is 2. Over here my value looks like it's close to 5. Here at 4 my value is like 7 or 8. So as I go this direction, the numbers on the green line, my points are getting larger. So this is a positive slope. If the opposite were happening, so as I was going this way, if the values on this green line were getting smaller, going from say 2 down to like -1, down to -5 or whatever, and they're getting smaller, that would mean my slope would be negative. So it's a negative or 8 over 6 if that were the case. Okay. Last piece, let's talk about reducing. So all I'm looking for is common factors. What do these have in common? And so if I know 8 and 6, I know that 2 goes into both of those. So I can reduce them both by 2. So I know 8 divided by 2 is 4. And I know 6 divided by 2 is 3. So that means this is the same thing as the slope of 4 over 3. And we can check that on our graph as a matter of fact. So we can go up 1, 2, 3, 4, and over 1, 2, 3, and voila. We see that point's on the graph, and that point is at 0, positive 2, which ends up also being my y-intercept. So there's my slope. Oh, I did some purple there. I want to keep that orange for you all. Okay. So if we go up 4, rise, and run 3 to the right, we still get to the same point on that green line. And we could go up 4, 1, 2, 3, 4, over 1, 2, 3, and then we get to the point 3, 6 that we started with. Okay. So that's how we calculate slope from a graph. Remember to always pay attention to if the values are getting larger or smaller. So we're looking at positives or negative slopes. And that negative would be out in front, float to the front, or go with the top number. But it's against the rules to put it with the negative on the bottom. It's just kind of like forgetting to put a period at the end of your sentence, kind of a thing. Okay. All right. So there is your final reduced answer, 4/3. If you got 8 over 6, your answer is not wrong. It's just not all the way done. I hope this helped you understand slope on a graph a little bit, and we'll see you in the next video. Bye.